And if you look at a CD, we know that, that as that laser moves toward the outer edge, the linear speed of the CD is going to depend both on how quickly it's rotating and how far away from the center of rotation that laser is. So if this is true, and it is, then what has to happen in order for the CD to be read properly? What has to happen to the rotational speed of the CD? If if this is my laser, directly underneath this laser as it moves this way, the point directly underneath it needs to be moving at 1.2 meters per second. If I start here and I move out this way, what has to happen to the rotation of the CD for that to remain constant? Yeah?
Wouldn't it need to slow down?
It has to slow down, correct. If you think about how quickly points here are moving at any speed, they're moving way slower than points all the way out here. This point in one rotation has to travel this distance. This point here has to travel a much smaller distance. If they both make one rotation in the same amount of time, which they better do if your CD is going to stay whole, then this point is moving faster. That breaks the rules of CDs, which means the CD player mechanism has to play the disc slower as it goes. It slows down as it goes. Yeah?
I assume that's more or less the same for DVDs?
No, I think DVDs it's the other way around. DVDs it's the laser that adjusts, but I'm not sure about that. You could do it either way. Record players, for example, record players don't change their rotational speed. Do you know how information is stored on a record player?
Yeah.
Yeah.
Grooves.
But it's not just the groove. The groove is where the needle goes. The information is stored in little bumps on the groove. And it has a left and a right side for stereo. And the height of the bump on the left and the right side makes the needle vibrate. And that creates electrical potential in the wires. And basically what happens is it reads bumps. The problem is, when you play a record, it's spinning faster when you start the record, right? On an album, it starts on the outside, and then the needle gradually moves into the center. So imagine if you were listening to your favorite song and it did the equivalent of this. What's your favorite song? It's probably Rapper's Delight, right? I said a hip hop, hip. But imagine if you put that on and it was like, I said a hip hop, a hippie to the hip hop, he does that, and it just sped up and got more and more high pitched as the record went. That would be weird. Probably the way that kids work these days, that would become the new hit music thing. But to my ears, that sounds bizarre. So how do they deal with that? It doesn't slow down. What do they do?
Well, because they're spinning the record with the music, like, playing. So they're creating the record using the music while the record is spinning, so it's automatically adjusting.
I'm not sure about that. They might be, but I don't think that's how they do it. I think they stamp those records. They stamp them out. Yeah.
They definitely have to take into account the fact that it's going to be faster, so you'd have to put the grooves farther apart or something like that.
It's not, so you're almost there, yes. Not that the grooves are farther apart.
I mean the bumps in the groove.
The bumps are farther apart, yes. So if you look at a record groove, as it goes, as that needle moves farther and farther away, those bumps move farther and farther apart from each other. So that the needle hits them at the same rate on the beat, right? Like these would all be like, if this was like the bass drum, boom, 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 boom. They're spaced such that they're they're farther apart as the linear speed of the record is increasing. Okay, so yeah, so we've got to slow down. We have to slow down a CD player in order to keep our linear speed constant as the laser moves from the inner to the outer diameter. All right. So, given that, here's the next question. And actually, we'll do both of these. So, the next set of questions is, if we have information on a CD that starts 25 millimeters from the center of rotation, it ends 85 millimeters from the center of rotation, keeping in mind that the linear speed underneath the laser always needs to be 1.2 meters per second, then how fast is the disc rotating at the start? And how fast is it rotating at the end? And when we talk about rotation, we're asking about angular motion, okay? So now, for those of you who would like, it would be a great time to take a break. I'm gonna pause the video. You take